Great returns are in luck, they're built on the floor. Operators and investors always pushing for more. From the deal sheet signed to the systems in place. Speed without precision is just running a race. Operational velocity, where execution sets the pace.
Hello and welcome to Operational Velocity. It's the summer of 1950, and at a hotel on a mountainside 90 minutes outside of Tokyo, a beautiful setting, hot springs, gardens, and on a clear day you can see Mount Fuji from the lawn. Inside the hotel there were 21 men, and every one of them ran a Japanese company, and between them, by one estimate, they controlled about 3/4 of the industrial capital of Japan. You have to understand that 5 years ago, their country was bombed flat. Their factories are rubble, and their products have a reputation. That reputation is cheap. Japanese goods are the punchline, tin toys, and things that break. And in front of them is an American. He's 49, he's a statistician, and his day job is drawing samples for the United States Census Bureau. He has a loud voice, and he's not necessarily charming, and he tells them, "Do what I say, and inside 5 years, the world will be begging for protection from Japanese goods." He was wrong. Years later, he put it like this: "They beat my prediction. It took 4 years." This is Operational Velocity, and this is Gautam Basu. Today, we're going to talk about William Edwards Deming. He handed Japan the playbook that took Detroit apart. At the time, almost nobody in America knew his name. And here's the part that should bother you. America had already had it. America invented it. And during the war, the United States trained more than 30,000 of its own people in these exact methods. Then it put the whole thing in the drawer. And we go into the room on the mountain and we'll do the bead experiment that has been embarrassing executives for 70 years. We'll take apart a Ford transmission where every single part was in spec and every single part was wrong. And we'll finish at Boeing in 2026 because for the last 2 years, the thing limiting the world's most important aircraft factory wasn't demand. It wasn't money. It wasn't engineers. It was whether a regulator believed their quality system. Deming died in 1993, and he's still the most useful person we've covered on this entire series. Let's go. William Edwards Deming was born in October 1900 in Sioux City, Iowa. When he was 6, his family moved to Powell, Wyoming. They were among the first settlers there, and it was frontier country, and they were poor. The Deming Institute describes what he took from that childhood in 3 words: a hatred of waste. And that's the right frame. He grew up somewhere, he didn't throw things away. And he works his way through University of Wyoming with odd jobs, janitorial work, engineering degree in 1921. And then a master's in physics and math from Colorado. And then Yale, a doctorate awarded in June of 1928 with mathematical physics. His thesis was on packing of nucleons inside a helium atom. And that last detail matters because Deming isn't a management guy who picked up some statistics. He's a physicist. His instinct for his whole life is simple. A process is a real physical thing. It has real behavior. You can measure that behavior, and the measurement either means something specific or it means nothing at all. Now, the 2 summers that make Deming. In 1925 and 1926, he works at Western Electric's Hawthorne Works in Chicago. Hawthorne is enormous, tens of thousands of people making telephone equipment, and is right then the most studied factory on earth. The famous Hawthorne productivity experiments are running while he's there. And in 1927, he meets Walter Schewarth. Schewarth is a physicist at Bell Telephone Labs, and he was working something out. Everything varies, every process, every day. The question is which kind of variation you're looking at. Some of it is just a system breathing. It comes from the machine, the material, and the method, the way work is designed. Schewarth called that common cause. It's there every day, and it belongs to the process. And some of it is a real signal. Something actually happened. A tool broke, a bad batch came in, a new operator started. And on a report, they look identical. A number went up, and number went down. His control chart isn't a statistics exercise. It's a decision rule. It tells you whether the number that just moved is telling you something or telling you nothing. And here's why any operator should care. There are two ways to get this wrong. Both cost money. The first is treating a common cause as a special cause. You react to noise. You demand an explanation for every dip. You launch a corrective action every time the weekly number wobbles. That doesn't just waste effort, it makes the process worse. Deming proved this for decades with something called the funnel experiment. Adjust a stable process in response to its own random variation, and the results spread further. Every time, not neutral, worse. He called it tampering. And the second way is the opposite. You treat a special cause as a common cause. Something genuinely broke, and you shrug, and because there's always variation. So you miss the one thing worth chasing. Two errors, opposite directions, both expensive. And almost every management meeting on earth is run with no method for telling them apart. Somebody puts up a chart this month, again last month, everyone argues about the gap, nobody asks whether the gap means anything. That's Shewart's question. Deming spent the next 60 years asking it, mostly in rooms that didn't want to hear it. And here's a part of the story that usually gets skipped. It's also the part that should worry you. In 1939, Deming joins the United States Census Bureau as an advisor on sampling. He brings sampling into 1940 census, better accuracy at lower cost. Then he does something nobody had done. He applies statistical quality control to the office work, the tabulating, the summarizing. And as far as anyone can establish, that's the first time these methods are used on a white-collar work anywhere. 1940. Then the war. 1942, Deming is retained as a consultant to the Secretary of War. A statistician at Stanford asks him how to help the war effort. Deming's answer is simple. Teach Shewart's methods to the people running war production. Short courses, 10 days, 8 hours a day. The first one runs that summer, 21 men from war, contract industries, and armed service procurement, plus 3 more. Then it scales. Deming personally taught 23 of these courses, and by March of 1945, they had been attended by more than 1,900 people. Those people came from 688 American industrial firms and 13 Canadian ones. But that's not the big number. The early students went home and became instructors themselves. They ran their own courses in their own plants, in their own regions. That cascade reached another 31,000 people. And if you look at what that produced, in just 3 years from a standing start, in the middle of a war, the United States built the largest industrial quality training program in history. The study groups those students formed became regional societies. Those societies became the American Society for Quality Control. You see, America didn't lack the knowledge. America built the knowledge, then trained itself in it at a national scale on a deadline. And then the war ended. And America looked around and found it was the only major industrial economy still standing. Europe was wrecked, Japan was wrecked, demand was enormous, and supply was short. And in that market, you can sell anything, anything at all. Quality stops being a differentiator, and when there's nothing to compare you to. So the charts came off the walls, the statisticians went back to the statistics departments, and the courses stopped. An apparatus built in 3 years took about 15 to rot. This is the lesson that travels furthest outside of manufacturing, so I'll say it plainly. Capability that isn't tested by the market rots, and you can see it happening while demand is strong. You never find out your quality system decayed during the boom. The boom pays for the rot. You find out in the first year the customer has somewhere else to go. By then, the people who knew have retired, and what's left is the paperwork without the practice. So if you run something right now that's selling everything it can make, this is your risk. Not the obvious one, this one. America filed Deming away around 1950, which is almost to the month when somebody else pulled him out. In 1947, MacArthur's occupation authority called Deming to Japan. Not for industry, for a census. They need to understand nutrition and housing in a destroyed country. They need somebody who understands sampling. And here's what separates him from every other American expert flown into Tokyo in those years. He treated the Japanese as colleagues, not as a beaten enemy. He learned the country, he made friends, and in 1947, they made him the first honorary member of the Japanese Statistical Society. 3 years later, the invitation comes the other way. The Union of Japanese Scientists and Engineers, JUSE, asks him to come and teach. The session was sponsored by Kinderrennen, the most powerful group of executives in the country. Their chairman is Ichiro Ishikawa. He also happens to be the president of JUSE. So Deming arrives in the summer of 1950 and he teaches. An 8-day course on quality control in Tokyo. 235 people, mostly engineers. He runs it again in Osaka for 150, and in Nagoya for 125, and Hakata for 85 people. Then he does the thing that actually mattered. He goes up to the mountain at Hakone to a hot spring hotel, and he runs a 1-day course for top management, company presidents, nothing else. And he explained why later. He knew he had to reach top management. Otherwise, the change would not stick. And anyone who has tried this type of work knows how it ends. Because Deming had already watched this fail once in America. He trained thousands of engineers. They'd gone back to their plants full of method, and then they hit a wall. Because the things actually govern quality aren't the engineers to decide. Purchasing policy isn't. Buying on lowest price isn't. Production quotas aren't. And ranking and rating people isn't. Whether the boss wants the honest number or the comfortable one definitely isn't. Teach the engineer and nothing structurally changes. Teach the presidents and everything can. That's not a quality insight. That's a change management insight. And it's why the Japanese program took and the American one didn't. So what did he tell them up on that mountain? Not statistics. He gave them a chain. Improve quality and costs go down. Less rework, less scrap, less waste, fewer delays. Costs go up, so productivity goes up. Productivity goes up, so you take the market, better quality, lower price. You take the market, so you stay in business. You stay in business, so you provide jobs and more of them. Now, hold that chain against what everyone in that room had been taught. They had been taught that quality costs money, that you buy it by the 10th of a point, that management's job is to decide how much to buy, and Deming's chain says no. In a badly run process, quality is free, better than free, because you're already paying for it. You're paying in scrap, in rework, in warranty, in expediting, in inspectors, in customers who don't come back. And you're already paying for the quality you don't have. He also refused to be paid for the 1950 lectures. He'd seen what Japanese finances looked like. So JUSE printed the transcripts, sold them, and used the money to endow a prize. And they named it after him, the Deming Prize. First awarded in 1951, 75 years later, it's still one of the hardest quality awards in the world to win. And now the scoreboard. Toyota brings statistical quality control in 1949. In May of 1965, it enters the Deming Application Prize. It submits its report in June, and the committee votes in October. Toyota wins. The ceremony is that November at the Imperial Hotel in Tokyo. Deming flies over for it, and the managing director who ran the quality push gets up to speak. His name is Surichiro Toyoda. He later run the company. Toyota's own corporate history records what he said changed. Going in, people still believed quality came from inspection. Through inspection, what replaced it was discipline, building quality into each process. That's the Toyota production system, in 6 words, in 1965. Now, what happens to the country with the filing cabinet? 1980, Japanese vehicle production passes 10 million units. Japan overtakes the United States as the largest vehicle producer on Earth. Japanese exports hit 5.97 million units that year. For the first time in history, more Japanese cars sold abroad than at home. Japanese makers hold about 21% of the American car market. Detroit's Big Three lose $4 billion in a single year. 300,000 plant workers get laid off. And in May of 1981, the American government does something remarkable. It negotiates a cap on Japanese car imports, 1.68 million units a year. 39 years later, that same government had trained 30,000 of its own people in exactly these methods. That's what forgetting costs. In June of 1980, NBC airs a documentary. It runs an hour and 16 minutes, and it's called If Japan Can, Why Can't We? America is genuinely frightened about productivity by this point. The program is trying to work out why the Japanese are eating everyone's lunch. And near the end of it, they put on a 79-year-old American statistician that basically no American executive has heard of. The producer, Claire Crawford Mason, rang him up a couple weeks before. She warned him it was coming. She warned him people would probably call. And they called. Every account of his life says the same thing. The phone never stopped ringing. He started running 4-day seminars that year. He kept them running for the next 13 years worldwide. Into his 90s, tens of thousands of people. And in those seminars, he ran an experiment. I want to take you through it properly. It's the most efficient piece of management teaching ever built. And it works on absolutely everybody. So here's a kit. A box with 4,000 wooden beads in it, 3,200 white, 800 red, so it's 20% red, and a paddle. 50 little dimples in it, 10 across, 5 down. One dip lifts exactly 50 beads. He recruits from the audience. 6 willing workers, that's his term, and he uses it completely straight the whole way through. 2 inspectors, a chief inspector to check the inspectors, and a recorder to write the numbers on the board. The company makes white beads. The company will not accept red beads. Red beads are considered defects. The standard is white 50 beads per worker per day. And the procedure is rigid. Pour the beads between the box to mix them, dip the paddle, don't shake it, carry it to the inspectors. They count separately, and the chief inspector confirms, and the recorder writes it up. And then Deming manages. Worker 1 draws 9 red, not acceptable. Worker 2 draws 6, better. There, 6 is possible, so we know it can be done. Worker 3 draws 12. What is going on with worker 3? Day 2, he posts the results on the board. He offers encouragement. He reminds everyone what the customer needs. And he puts up a slogan. He brings in merit pay for the best performer. He puts the worst one on notice. Day 3, the best worker from day 1 draws 11 red and gets a talking to about complacency. A man who is on warning has a great day and gets held up as proof that accountability works. Day 4, business is bad, so he lays off half the workforce and tells the supervisors to pick up the slack. And then he closes the plant. Now, 20% of the beads are red. Every worker, every day, dips the same paddle into the same box, following the same procedure. The expected number of red beads is 10, every draw, for everybody. The workers weren't different. The days weren't different. Nothing anyone did move the results by a single bead. Not the slogans, not the merit pay, not the warnings, not the firings, not the encouragement, and not even the accountability. None of it was connected to anything. 2 things decided that outcome: the proportion of the red beads in the box and the design of the paddle. And exactly 1 person in the room had the power to change either. He's the one doing the shouting. And every single time he ran this for 13 years across thousands of people, the room would rate the workers. They'd rank them, reward the top one, believe in the difference. Because the numbers were right there on the board, and they were genuinely different. They were different the way the coin flips are different. Here's his own estimate, and it's from the book Out of the Crisis. And it's what this episode is named after. 94% belongs to the system, and that's the responsibility of the management, and 6% is special. 94-6. Now, how long did it take corporate America to agree? He published that in 1982 in the same book he said to abolish the annual merit rating. November 2, 2013, 31 years later, Microsoft's head of HR emails the entire company and kills stack ranking. No more forced curve. Managers no longer have to spread their people across a distribution. They no longer have to label a fixed share of the teams as underperformers, no matter how the team actually did. The internal phrase was, no more curve. General Electric walked away from this too. GE, the company that made Rank and Yank a global export. So did Adobe, so did Accenture, and Amazon moved off of it. Actually, every one of them worked out at enormous cost in people and morale, what a man with a bucket of beads had been demonstrating in a hotel conference room since the 1950s. If the system produces the outcome, then ranking the people isn't inside the measurement. It's superstition with a spreadsheet. Ford Motor Company, start of the 1980s, real trouble. Between 1979 and 1982, Ford lost around $3 billion. And in 1981, Ford became the first big American company to call Deming in. He was 80 years old. Everyone tells the same story about that first meeting. They tell it because it's true, and because it's the whole thesis in one scene. Ford wanted to talk about quality. Deming wouldn't talk about quality. He wanted to talk about management, their culture, how their managers behaved, what their policies were actually rewarding. And then he told them the thing that landed like a brick. The overwhelming majority of their problems building better cars were caused by management. Not the line, not the union, not the workers, them. Now here's the part I want you to take away. It's technical, it's specific, and it's worth money. 1983, Ford had an automatic transmission. They designed it. It gets built in two places, by Ford in Ohio and by Mazda in Japan. Same design, same drawings, same specification. But the warranty claims are wildly different. Mazda's units are dramatically better. So Ford does the sensible things. It pulls the units from both plants and takes them apart. And here's what the inspection found. Every single part from both plants was inside specification. Both plants were conforming, but both were, by the standard of the Western manufacturing world, at that moment doing the job correctly. The difference, however, was where inside the tolerance band the parts sat. Ford's parts were scattered across the whole allowed range. Anywhere inside the limits was a pass. So anywhere inside the limits is where they ended up. Mazda's parts were clustered tight around the target, the middle of the band, the number the designer actually wanted. Ford's process was aimed at not failing inspection, whereas Mazda's process was to aim at the target. Now stack up a gearbox full of parts that are technically acceptable and individually a bit off. The tolerances add up, the fits get loose, and the gaps go wrong. And the whole assembly is worse than the sum of its conforming parts. Mazda was working from Genenji Taguchi's loss function. The idea is this. Quality loss doesn't jump from 0 to infinity the moment you cross the spec limit. It rises steadily the further you get from the target. A part that's just inside the limit isn't good. It's nearly bad. And it costs you nearly as much. Which is why where within the spec is one of the most dangerous sentences in operations. Conformance is a pass-fail gate. It's binary, and it's set by whoever drew the drawing, and tells you nothing about the distribution of the process. You see, two plants can run both at 100% conformance, and one of them can be quietly destroying your warranty line, your reputation, and the asset you paid a multiple for. The money isn't in the defect rate. The money is in the variance. So if you take one thing out of this episode, take this. Pick your most important part or process, and then go and ask a different question. Not what's our rejection rate, ask, show me the distribution. Where does it sit relative to the target? How wide is it? And is it stable? If nobody can answer that, you don't have a quality system. You have an inspection department. Those are not the same thing. Deming spent 40 years saying it. Inspection is too late. By then, the quality is already in the product, good or bad. So what did Ford get? The Taurus and its twin, the Mercury Sable, launched in 1985 for the 86 model year. 5 years of development, $3 billion, rounded aerodynamic front-wheel drive, built using the statistical approach Deming bought in. Ford expected to sell about 325,000 of them in year one, which is considered an extraordinary debut. And in 1986, Ford earned more money than General Motors. Ford was about half of GM's size. That hadn't happened since 1924. That's 62 years. Then it happened again in 1987. Ford posted $4.6 billion in profit on $70.16 billion of sales, an industry record at the time. And Peterson, the CEO who bought Deming in, went further than the numbers. He got rid of the executives' parking spaces. He got rid of the executive dining room. He talked publicly about driving fear out of the organization. That phrase isn't his. It's Deming's. It's 0.8 of 14, and it's the one Deming cared the most about. Because where there's fear, you don't get honest figures. And if you don't get honest figures, everything else you do is theater. So, here's the uncomfortable question. If it worked in Japan and it worked at Ford, why isn't every company on earth run this way? Because what America imported in the 1980s wasn't Deming's philosophy. It was Deming's vocabulary. The country had ignored him for 30 years. Then it discovered him at 80, panicked about Japan. And it did what big organizations always do with an idea that requires them to change themselves. It turned it into a program. TQM, Total Quality Management. A department, a steering committee, a binder, a launch event, posters in the canteen with a target on them. Point 10 of 14 says, get rid of slogans and targets aimed at the workforce. Not because encouragement is bad, but because the causes of poor quality mostly sit in the system. They're beyond the reach of the person you're exhorting. So the poster achieves nothing except to imply the problem is that they aren't trying hard enough. There's footage in that 1980 NBC documentary of a company Deming personally worked with. There are quality slogans on the wall behind them. He wrote 14 points because he thought the whole prevailing style of management was wrong, root and branch. He watched it get laminated and pinned up next to the coffee machine. I'm not going to read you all 14. They're free from the Deming Institute, and they're in the show notes. But in operator language, the spine of this, constancy of purpose, decide what the business is for, stay pointed at it longer than any one budget cycle. Stop buying on price tag, think total cost. Fewer suppliers, longer relationship, a cheap component that varies is not cheap. Stop depending on mass inspection, build a quality upstream. Improve the system constantly, not as a project with an end date. And institute leadership, not supervision. A supervisor's job is to help the person and the machine do better work, not to count. And drive out fear. Break down the walls between departments. Design, sales, production, service are one system, whether you organize them that way or not. And get rid of numerical quotas, management by the numbers and the annual rating. Late in his life, he put a frame around all of it. He called it the system of profound knowledge. 4 lenses, and you need all 4 at once. Appreciation for a system, knowledge about variation, a theory of knowledge. How you know that what you believe is actually true. And psychology, how people really work, and how easily a management system destroys them. That's the last book, The New Economics, which was published in 1993. He was still working, and he founded the Deming Institute that same year. And somebody asked him in his 90s, why is he still going so hard? And he said, so much to do and so little time. He died on the 20th of December, 1993, at home in Washington. He was 93. Along the way, in 1960, the Emperor of Japan gave him the Second Order Medal of the Sacred Treasure. 30 years later, somebody asked him how that had felt. He said he felt unworthy. He said he'd been lucky. From the man who spent 40 years explaining that individual outcomes are mostly a property of the system you happen to be standing in, that isn't false modesty. That's just him being consistent to the end. Let me bring this all the way forward, because I don't want you to file Deming under history. On the 5th of January, 2024, a door plug came off of an Alaska Airlines Boeing 737 MAX 9 in flight. What happens next is the most expensive live demonstration of Deming's argument in modern industrial history. And it's still running. The FAA's response wasn't mainly to inspect harder, it was to cap production. Boeing was frozen at about 38 aircraft a month, the rate it was already running, and banned from going higher without explicit approval. Dozens of inspectors into Renton, detailed manufacturing quality plans required before any rate change would even be discussed. Then, October 20th, 2025, the cap lifts to 42. Boeing's own first quarter 2026 filing has the program running at 42, planning for 47, with the FAA's agreement. And on the 27th of May, 2026, Boeing's CEO confirmed that they passed the FAA's capstone review were the rate of 47, and the line is running at that rate now. Now count it up. That's roughly 28 months in which the thing limiting one of the most important aerospace franchises on the planet was not demand, and the backlog is enormous. It's not capital, not engineering talent, not the design. The limit was whether the outside party believed the quality system. And the output of the factory was set for over 2 years by the credibility of the process. That isn't a safety story, it's an operating story. And it's exactly what Deming went up to a mountain to say in 1950. Quality isn't a department. It isn't an inspection stage, and it isn't something you bolt on when it becomes urgent. It's a property of how the whole thing is managed. And when it fails, it takes your capacity with it. So, the 5 things the operator's Deming. Number 1, know which kind of variation you're looking at. Before you react to a number, work out whether it's a signal or noise. And without a method for that, every corrective action you launch is a coin flip that costs money. Number 2, stop tampering. Adjusting a stable process in response to its own randomness makes it worse. Reliably. The monthly review that demands an explanation for every wiggle isn't rigor, it's the funnel experiment with a slide deck. Number 3, conformance isn't quality. Distribution is. In spec and on target are different things. Take your most important process and ask where it sits relative to target, not whether it passed. Number 4, 94% of it is yours. When performance disappoints, start with the system, not the person. Not because people don't matter, but because that's where the leverage actually is. Number 5, fear is a data problem. Where people are afraid, you get the numbers they think you want. Then every decision downstream is made on fiction. Driving out fear isn't a value statement. It's a measurement control. The lesson of the red beads is that a bad system will beat a good person every time. And you don't get to choose whether you have a system, you have one. It's producing exactly the results it's designed to produce right now, today, whether or not anybody ever drew it. The only thing you choose is whether you're managing it or blaming the people standing inside of it. This concludes this episode of Operational Velocity. I am Gautam Basu. If you like this podcast series, then please subscribe. This helps the show out, keeps it going, and also forward it to an operator that may enjoy listening to it. Until next time, take care.
Great returns aren't luck, they're built on the floor. Operators and investors always pushing for more. From the deal sheet signed to the systems in place. Speed without precision is just running a race. Operational velocity, where execution sets the pace.